Look, we're going to do it the formal method. Whether you guys do your arrows or your box method, it's up to you. So, and just because I said that, I know I'm probably going to like make a mistake, so joke's on me, right? Okay, you get this the formal way. Okay, so this is if you're doing it correctly, you decide to repetitively multiply the distributive property, like repetitive distributive property. Okay, what Pascal's triangle in the binomial expansion says is that, okay, Pascal's triangle gives you a shortcut. And so Pascal's triangle is, okay, you start with a 1 and you make a Christmas tree, kind of like 1 and then 1, 1. And now each row is going to be, you always start with a 1, and then this becomes an addition, so that's 2, and then you end with the 1. So then, oh, here, by the way, here's rows. So this is row, or not, exponent to the first power, to, whoops, the 0th power, to the first power, to the second power. Okay, so if you have a cubic function, right, like this is a cubic, like a 3, all right, exponent of 3. You would go 1, add them together, 3, add it together, 3, and then you end with the 1. So if you're in the 4th exponent, 1, this is 4, this is 6, this is 4, and this is 1. And so then it'd be 1, 5, 10, 10, 5, 1. And it would go that way. Okay, and so that's the Pascal's triangle right below here. Except it looks that they didn't align the numbers nicely, so this actually, it starts dropping a little. So like 6 actually isn't there. It's 6, 1, 15, 20, 15, 6, and 1. Okay, so your rows are a little off on that Pascal's triangle. Okay. You also need to know the binomial expansion. So it's both of these together. Okay, your Pascal's triangle is your exponents. Okay, so if I had a 2, whoops, if I had a squared exponent, a 2 exponent, then if I want to start doing this, a 2 is 1, 2, 1, right? It's 1, 2, 1. So that means I'm going to have 3 terms. So if I'm going to start using, right, it's right here, I'm going to have a 1, a 2, and a 1. Okay? If you want to watch it after and then kind of, don't get wrapped up in trying to copy that you lose it. Okay, 1, 2, 1. Now, where does the rest come in? Binomial expansion. So these are your coefficients. So if you notice, there's my 1 term. It's a monomial. There's my 1. If you have it to the first, a binomial to the first power is 2 terms. There's your 1 and 1. And then notice 1, 2, 1. 1, where am I? 1, 3, 3, 1. Those are your coefficients. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So Pascal's triangle, if you know what you're doing, most students just need Pascal's triangle. They don't need the binomial expansion because I'll then show you guys what you're doing here. It's actually not hard. If you can count down and you can count up, you don't need to have this reference. All you need is this. You just need to build your little Christmas tree. Okay, so how do we build it? Okay, if I have to the second power, if you look here, it's 1, and then if you notice, it's a squared, right? So it's that first a to that exponent 2. And then if you notice on the next term, a decreases by 1 exponent, by a degree. So it goes 2, a to the 1, and notice there's no a on the third term. So the first term in your binomial is decreasing. It starts at this exponent and it goes 2, 1, 0. What's the second term in the binomial? It goes up. It starts at 0 and it goes to 2. So there's no b here. B to the 0, b to the 1, b to the 2. So the first term is decreasing. The second term is increasing with your Pascal's triangle coefficients of 1, 2, 1. Okay, so Trying to apply that, all right? And then we'll do a 4, and then we'll jump to 4, because why not? All right, I need to know what the problem is, so hold on. 9b minus 1 squared. Okay, so what is my A term here? My A term is 9b, right? So if I follow this, it's going to start at 2, 1, 0. So that means my 9b is going to be at the second power as the first power, and then here it's the 0th power. If you want to write the 0, you can, but you can just leave it off. Anything to the 0th power is 1, right? So what do you guys want me to write? Do you want me to write the 9b to the 0, make it look messy, or do you want me to just write the 1, or you just leave it off? Just write the 1? Okay, if you want to write the 1, you can write the 1. But this is really 9b to the 0th power. You have to decrease. This is on a decrease, 2, 1, 0. This one is on an increase. This minus 1 is the b term. This one increases, 0, 1, 2. So here you could just put the 1 there, but it's really minus 1 to the 0, right? Anything to the 0th power is 1. So this is negative 1 to the first, and this is now negative 1 squared. So the first term decreases to 1, 1, right? It goes to 0, 0, which is 1, 1, 2. Clean that up, and you're going to get 81, 18, and positive 1. So if I want this, okay, well, I have 1, right? 9 squared is 81, b squared, right? So I don't need the 1, so I basically have 81b squared, and that's what I have so far. Okay, 2 times 9 is 18, times negative 1, negative 18, and I have 1b, and so far it matches. And then here, 1 times 1, negative 1 squared is a positive 1, so there's my positive 1, and there's your calculation. That's how it works. That's it. Okay, it can get messy, it can get ugly, kind of. You have to just make sure you always go back and look at, did I decrease right? 2, 1, 0, 1, 0, 1, 2. And then just get your Pascal's triangle. Sometimes students forget the Pascal's triangle. They'll get the decrease right, they'll get the increase right, and then they forgot these numbers. Okay, so let's try another one. Oh, well, how long is this video going to be? Let me shut it off and then let me record again. Yeah.